Hi, I'm Brian Costley from Sargent and Greenleaf. In this project, we're going to install a mechanical lock, a standard Group 2 type lock, on this safe where there is no lock currently. First, we'll open the door. It's a good idea to immediately block the frame so that we don't accidentally close the door while we're doing our installation. The next step is to hold the relock device in check. That's a spring-loaded plunger, which if we don't hold it back, will securely lock the safe when we close the door and turn the handle, and we don't want that to happen during our lock installation. So now it's held in check with the vice grips. Here's our lock body. This is a model 6730, a standard Group 2 type lock. I've removed the cover screws. We can take the cover off, and this will be necessary in order to mount the lock on the safe's mounting plate. This will be a vertical down mount because the bolt of the combination lock will interact with the bolt work down on the bottom side. So with a bolt pointing down, that's called a vertical down mount. In some safes, it could be a right-hand mount like this, or it could even be a left-hand mount, or it could be a vertical up mount. Same lock mounted 4 different ways: vertical up, left hand, vertical down, or a right hand. And of course, we're going to be mounting vertical down in this particular application. These are the mounting screws that come with a lock. They're 1/4-20 machine screws. You notice that one of the screws I've already used here, so we've got 3 mounting screws left that are 1/4-20 and 3/8 of an inch in length. We also have shorter 1/4-20 screws. If the mounting plate for the safe is thick enough to accommodate the longer screws, we use those. If the mounting plate for the lock that's in the safe does not accommodate the longer screws, then we're going to have to go to the short screws. And you notice they have a red substance in the threads. That's called vibratite. It's a dry thread sealing compound, and if we're using shorter screws, we must use screws that have some type of thread sealing compound. Otherwise, those screws are likely to work loose over time, and that will lead to either degraded performance of the lock, or it will lead to total lock failure. We'll go ahead and put in these remaining 3 1/4-20 by 3/8 screws. We've got 3 of the mounting screws in. This is the 4th one. By the way, the use of a magnetic screwdriver will make your life a lot easier. Once we have all screws in loosely, we can go ahead and tighten the last one we put in. Work up diagonally to the other corner, tighten. We can drop down to the bottom of the lock, tighten, work diagonally again, and tighten the top screw up here. Now we've tightened them all evenly, and the screws are all really tight, not just snug, but very tight, holding that lock to the safe's mounting plate. Once we have the lock firmly mounted on the mounting plate, let's pull the drive cam out. Set that aside for the moment. We're going to use something called a dial ring alignment tool, which is a couple of bearings on a straight shaft, and there's a threaded barrel on the end that we use to pull everything together. On one end of our dial ring alignment tool is a bushing with a W on it that goes in the wheel post, and everything else that we're going to do is from the other side of the safe. So we'll go to the front now. Here's our dial ring. It's a black painted ring. It has an opening index, and it has a changing index. We've got 2 mounting screw hole locations, and we have a large opening in the center where we will insert a Delrin or a plastic type dial ring bearing. We do that from the back. We turn the dial ring over, insert the dial ring bearing, and it just presses into place. And if we have it inserted correctly, the back of our dial ring and bearing is flush right across. We also have our 2 dial ring mounting screws. These are 832 machine screws. Before we fasten the dial ring to the front of the safe door, we will install one of the bushings. This one has a D on it because it goes in the dial ring, and this is part of the dial ring alignment tool. Once we have this installed in the dial ring bearing, we can push the whole assembly against the front of the safe. Now we take the threaded barrel assembly from the dial ring alignment tool, thread it over the end of the dial ring alignment tool shaft, and we just want to snug it up. It's not real tight, but it's fairly snug, and what that does is it pulls the center of our dial ring into perfect alignment with the center of the wheel post inside the lock. That brings everything into absolutely perfect alignment. We can still rotate the dial ring so that it looks like it's straight up and down and in line with the other components on the safe door. But the center is exactly aligned with the center of the wheel post of the lock inside the safe door. Once we have it in this position, we can install our 832 dial ring attaching screws. Notice we leave the dial ring alignment tool in place while we do this, and I've not yet really tightened up these screws because I want to make sure I have a good visual alignment of that dial ring on the safe door before I do that. Now I'll go ahead, tighten those down. Now I can remove the threaded barrel from my dial ring alignment tool, take the bushing off the shaft, pull the other side of the tool out from inside the lock, and I'm done with my dial ring alignment tool. This is the dial assembly for our lock. You notice, of course, it has the numbers on the front, it has the grip. It also has a threaded brass spindle. This brass spindle is what transfers your dialing motion from the front of the safe to the lock components inside. The dial seats in the dial ring and the dial ring bearing, and we'll have to go to the inside of the safe to thread the drive cam onto it. Here's the drive cam, which we removed from the lock when we were going to use the dial ring alignment tool. It has internal threads that match the threads on the dial spindle, so I'll hold it onto the end of the spindle. From the other side of the safe, I'm turning the dial, and you'll notice that the spindle is threading right through the drive cam. As I'm sure you've noticed by now, we have a lot of excess spindle material. So in order to be able to cut the spindle to the correct length, and yes, we will have to do some cutting, we need to thread the drive cam all the way down until it is seated inside the wheel post. Notice we move the lock lever out of the way so it doesn't get caught between the underside of the drive cam and the top of the combination wheels. And now we have it threaded in until it's just snug. In order to know where to cut it, we need to mark the spindle. We can just take a regular marker and we'll mark it where the excess comes through the back of the drive cam. I've taken the dial and the spindle back out of the lock, unthreaded the drive cam, and then once I had the dial disconnected from the lock, I went ahead and threaded the drive cam back on. You'll notice I have my mark. It shows me exactly where I'm going to cut the spindle. After I cut the spindle, I will dress the end of it so that it has a slight bevel, and then I'll thread my drive cam back off. Any threads on this spindle that have been deformed in the cutting process will be brought back into the proper shape just by the action of unthreading or taking this drive cam back off of the spindle shaft again. I've cut the spindle where it was marked. I've dressed the end of the cut area with a file, and now I can thread the drive cam off the end. And remember, any threads that I've deformed will get put back into the proper dimensions just in the act of unthreading this drive cam from the spindle. Next step is going to be to install the dial. Before I do that, this is not a required lubrication point, but I'm going to take just a little dab of a high-grade synthetic-based lubricant. I don't want to use a petroleum-based lubricant because it may react adversely with the material in the Delrin dial ring bearing. And so I'm going to take just a little bit of this lube and put it right there on the underside of the dial. Now I can install the dial in the dial ring from the front. You can see it right here in the center of the wheel post. Place the neck of the drive cam over that. Notice I'm holding the lever out of the way with one finger, supporting the drive cam with another one, and I thread the spindle back into the drive cam. Here is a very important point in the installation. I'll use a laser pointer to show that we have letter designations stamped into our drive cam. There is LH, that stands for left hand. VU stands for vertical up. RH stands for right hand. VD stands for vertical down. You'll notice that next to each one of these double letter designations there is a small slot, which we call a spline keyway, that's milled into the drive cam. There is a single slot, or spline keyway, milled into the dial spindle. This lock is mounted vertical down. We can tell because as we look at the back of the lock, the bolt is pointing down. So we need to align the single spline keyway in our spindle with the correct letter designation, which would be VD for a vertical down mount. So we hold the drive cam and unthread very slightly the spindle from the drive cam until we get a close alignment of the single spline keyway in our spindle with the VD spline keyway in the drive cam. This little brass piece is called a spline key, and as you may have guessed, it goes in the aligned spline keyways that you just put into proximity with each other between the spindle and the drive cam here at the VD splining position. As you can see in this close-up, with our spline key partially inserted, the head or the flag of the spline key goes out over the drive cam. It does not cross towards the center of the spindle. This is the correct orientation for the spline key. With the spline key partially inserted, I come to the front of the safe and I just want to check the action of the dial. I'm looking to make sure there are no spots in the rotation where I get rubbing or binding between the dial and the dial ring. Because my installation was accomplished with the use of a dial ring alignment tool, it would be very unusual to come across any binding. However, if I were to install the dial ring without the aid of a dial ring alignment tool, I would very likely find some spots in the rotation where the ring does rub against the dial. In that case, I would look for places around the dial where it rides lower slightly in the ring than at other spots around the circumference. Then I would correct that basically with a little brute force. I would use a saw-faced, either a plastic hammer or a rawhide-faced hammer, and I would strike the dial ring sharply at the point where the dial rides lower in the ring. I would then go back and check my rotation and see if I had relieved that binding, and eventually I will relieve the binding. Remember, always strike the dial ring, never strike the dial itself, or there's a chance that you'll bend the spindle. Once your spindle is bent, it can never be straightened, and you'll have to use a different dial and spindle assembly. Once I'm satisfied with my dial action, I can go ahead and seat the spline key. Again, I use a small lightweight hammer, and I strike the spline key on the top smartly. And if you look very closely, you'll notice that the underside of the head of the spline key is just barely touching the top surface of the drive cam. It's now fully inserted. It's friction fit. In other words, it deforms slightly when it's driven into place. And we have a good firm connection between our drive cam and our spindle. In order to prepare our lock for actual use, we'll need to set a combination on it. And after an installation, you may not have any idea what numbers are set into the wheels, and so it'll be difficult to simply dial the lock from the front to set it up for a combination change. We'll align the wheels manually, and then we'll have everything set. You notice I take a tool. This is just a hex wrench, and I'm moving the wheel by putting the hex wrench in this cutout in the edge of the wheel. This is called a wheel gate, and I move the top wheel gate until I find the cutout in the wheel below so that I can move those two wheels together, and then I move those two together until I find the cutout or the gate in the bottommost wheel. Once I have all three wheel gates aligned together, and I can move all wheels with my hex wrench in the wheel gates, I move those wheels counterclockwise until my hex wrench is caught in the hook of the lever nose, and I leave the wheels in that position. One other thing I want to mention before we put the cover on the lock is the torque adjuster. You notice these gear teeth on the edge of a disc here, and they mesh with the gear teeth on a little pinion gear. You may receive with your lock a small 3/32 inch Allen wrench, which is designed to seat in the pinion gear of the torque adjuster and allows you to rotate this. What the torque adjuster does is it determines how much friction is present between the components of the wheel pack. It does have an effect on how hard it is to turn the dial, but that is not the purpose of the torque adjuster. The main point of showing you this is to be sure that you don't make any adjustments on the torque adjuster. If you do, you may severely lessen the security of the lock mechanism. So the torque adjuster, while you have a tool sometimes provided to make an adjustment, it's a very tempting target, but the best thing to do is simply not make any adjustments. It's factory set before the lock is shipped, and it should be left in that setting. Our wheels are in position, so we can install the cover. This is very likely going to be a temporary installation because we have a plate that will go on over the back of the lock cover. Once we have our two cover screws in place, time to insert the change key. You notice we make sure it's fully inside the lock case. There is a small raised section, or what we call a flag, on the change key that wants to be completely inside the lock case. Once the change key is fully inserted, we turn it 90 degrees counterclockwise, which is the only direction it will turn in. And as we do so, we feel and hear a release of tension inside the lock. The lock is now prepared to accept a combination. Before we set the combination, we need to be aware of a few things. This is the opening index at the 12 o'clock position. It's sometimes referred to as the crow's foot. It's used when we're dialing our combination to open the safe. To the left is a straight, short index, and this is the changing index. When we're preparing a lock for a combination change or actually setting in the new combination numbers, we dial to this mark. We also need to be aware of a few rules for selecting good combination numbers. We do not want to set the last or third number of the combination in this span between 90 and 20 on the dial. That only applies to the last or third number of the combination. Otherwise, we may experience a mechanical interference inside the lock, and the lock function, well, it may freeze up, and we'll need a technician in order to reset that for us. So we simply avoid the third number of the combination being set between this span of numbers between 90 and 20 on the dial. We also want to keep adjacent numbers of the combination at least 5 numbers apart. We want to avoid strictly ascending or descending combination sequences. For instance, we wouldn't want to use a combination of 70, 80, 90. A better combination would be 70, 90, 80. So we avoid strictly ascending or descending sequences. We also want to stay away from easily guessed numbers. Don't divide up the digits of your phone number or your birth date or any other easily guessed number. For security reasons, it becomes obvious why you want to avoid doing that. In order to set the combination, we need to be viewing our changing index straight on. When we're dialing our combination to open the safe, we will view our opening index straight on. Don't look at it from either side. If you look at the index mark from an extreme angle, you'll introduce an error automatically in dialing. We begin anywhere on the dial. We don't have to start at 0, a commonly held misconception. We start anywhere. Remember, our change key is inserted and turned, so we're setting a combination, and we're going to pick a good combination of 12, 87, 22. We turn our dial counterclockwise at least 4 times, and we stop on our first number of 12. If I go past my number even slightly when I meant to stop on it, I go around again and I stop precisely when 12 comes to my changing index. Now I'm ready to set in my next number, which is 87. I want to pass it twice, going to the right or clockwise, and stop the third time it comes to the changing index. There's once almost immediately. Remember, we're going to pass it twice. That's the second time. We're going to stop the third time that 87 comes to the changing index. There we are precisely. If we go past it when we meant to stop on it, even by a fraction of a number, we start all over again at least 4 times left to the first number of the combination. We've set it correctly so we can move on to the third number of our combination, which is 22. We'll pass it once and stop the second time it comes to the changing index. There's once almost immediately. We pass it once, we stop the second time it comes to the changing index. There we are precisely on 22. If we go past it when we mean to stop on it, even by a fraction of a number, we begin the combination changing sequence all over again, beginning 4 times left to the first number of our combination. Once we've set in the last number successfully, we turn the dial back to the right about 10 numbers. You don't have to be precise. We're just taking 2 parts that were in touch with each other inside of the lock, out of contact with each other, so that as we go to the other side of the safe door and turn the change key back, if we move something slightly, bump it, as far as the dial is concerned, we won't alter the combination that we've set in. From the inside of the safe, turn the change key clockwise 90 degrees. You'll feel a little resistance. Once it's turned 90 degrees, then pull it out. Don't pull at the same time you're turning. Turn it and then pull it straight out. Your combination is set into the lock. Your change key is removed. A combination change is not complete until you check your combination, and you need to check it low and high. You remember when we had the cover off of our lock, the color of our lever was a yellowish metal. It's brass. When we see a brass lever in a lock, that tells us that our dialing tolerance, or in other words, how much we can dial lower than or higher than the set combination number, is 1/2 of a number, and the lock should still open. If we had seen a gray or a silver colored metal lever, then our dialing tolerance would be plus and minus 1 full number. So we're going to check our combination of 12, 87, 22, 1/2 number low and 1/2 number high. We turn the dial left at least 4 complete revolutions, and then we will stop when 11 1/2 come to our opening index. We reverse directions. Remember, 87 was our second number. We pass it once. We pass it twice. On the third time, we want to stop 1/2 number lower than 87, so we're going to stop at 86 1/2 at the opening index. And now we'll dial to the last number. We dial left 2 times to 22. There's once. We stop the second time. We're going to stop a 1/2 number lower, so we stop at 21 1/2. We then dial back to the right. We feel resistance at about 6 or 7 on the dial. We keep turning to the right, and our dial comes to a positive stop at about 96, 97, possibly 98. We can verify that our combination lock is unlocked by operating the safe's handle. We've successfully dialed our combination numbers 1/2 number low. The next step, as you might expect, will be to dial our combination numbers 1/2 number high. We turn the dial left at least 4 complete revolutions and stop when our first number plus 1/2 comes to our opening index. First number is 12. We add 1/2, 12 1/2. We then reverse directions. Remember, our second number is 87, so we dial to 87 1/2 the third time that it comes to the opening index. This is twice. Here is the third time for 87 1/2. We then reverse directions again. We dial to the left. Remember, our last number is 22, so we're going to dial to 22 1/2. The second time it comes to the opening index. This is our second time, 22 1/2. Then as we dial back to the right, we feel a little resistance at about 7 or 8. We keep turning to the right, the dial comes to a positive stop, and then about 10 more numbers. And now we can verify that our lock is unlocked by again checking the handle as we did before. As we saw early on in this installation, our safe has a relock device, which is a spring-loaded plunger, and we've got it held in check with a pair of vice grips, but under normal operating conditions, we need a plate that is attached to the cover screw locations of the lock case, and that will hold the relock device in check. Well, it wouldn't make sense to leave our vice grips there, now would it? In case a burglar performs a punching attack on the safe, when the lock cover breaks due to the punching, the relock device holding plate will come away with the lock cover, and it will allow the spring-loaded plunger to engage the boltwork in the safe, and the safe will be re-secured. There are a couple of things we need to watch out for. First of all, the original cover screws in the lock case have tapered heads. Well, it won't do to try and use a tapered head screw against the flat surface of our relock device plate. What we'll do is we'll replace the taper head screw with a slightly longer screw that has a flat head where it contacts the relock device plate. Remember, we're going to use the longer screw because, first of all, we have to traverse an area of the lock case which is tapered to accept the original cover screw. Also, we have a slight thickness in the relock device plate itself. Once we have our relock device plate installed and tightened down at the cover screw locations of the lock using the slightly longer 832 machine screws, we can release our vice grips that held our relock device in check. It's now being held in check by the relock device plate, which is attached to the lock cover. So now, if our lock was open, we'd be able to move the boltwork back and forth free of any restraint from the relock device. It's a good idea, once we've installed the relock device plate, to dial our combination from the front of the safe, retract the lock bolt, check the motion of our boltwork a few times, and if everything is working satisfactorily, it's time to put the back plate on the door. This safe has a very easy to replace back plate. There are slots in the door frame, corresponding hooks in the back plate. So once you get those lined up, you can slide the back plate into place, and then you have one screw location at the top. So we install that single screw. Once you do that, the back plate cannot slide up and come off the door. And there's even a decorative cap that goes over the top of that screw. So now we have everything in place. We can unblock the door. And the last thing we need to do is check our combination again with the door open before we close the safe. And we enter our combination one last time. 22 is our last number. We come back to the right. We feel a little resistance. Keep turning to the right. Our dial stops at about 96 or 97. We check the handle, make sure that our lock operates correctly. And this is really the final check we need to do before closing the safe, operating it one more time, and then our installation is complete.